On 238, the reason we use long and synthetic division when we do polynomials is because sometimes we get into things that we don't know how to factor. Is it 238?
It's 245.
245? I don't know what I'm talking about. 245. Page numbers. Who knows? All right, so like I said, division is another way that we use to factor polynomials. If we don't know how to factor something, like for example, question 1 right there, if you had 2x cubed plus 11x squared plus 9x plus 2, you could try to put that in the box and factor. Wouldn't necessarily work. So it's another method we use to factor out stuff. We use it for several different reasons, but we'll talk about most of them today. Long division is the one that we typically don't remember how to do. Synthetic is the easier one, and we'll talk about that second, but long division is the one that takes a little bit of practice. So let's set up a couple of these, and then we're going to do a little practice on our own. So when you set up long division, it's just like back in like 3rd or 4th grade, whenever they taught that to you. You set up what you are dividing by on the outside. So 2x plus 1 goes on the outside. What you are dividing into goes on the inside of the bar. The one thing you have to watch out for is if there's any skips in exponents, you've got to put in a placeholder or a 0 for that. So in other words, this one goes to the 3rd power, to the 2nd power, to the 1st power, and then to the 0 power. So you have all the powers in a row on this one. So there's nothing to skip here, but we'll see that, I believe, on the next question. So if there's any missing exponents, you got to put that in with a 0. All right, so I color code this completely when I go through these, so you'll kind of see what I'm talking about. When you start long division with polynomials, you start the first term inside, which is this 2x cubed, divided by the first term outside. If you can do that in your head without writing it out, that's great. If you can't, you may always go out to the side, do 2x cubed divided by 2x, write down what you get. When I divide those two, what happens to my 2's? Cancel. So what do I get as an answer out of that? X squared. Now, when we put that on the top of the division bar, it lines up with the exponent that it goes with. So that's an x squared. It goes over the x squared term right here. It doesn't necessarily matter as far as getting your answer correct where it goes, but it gives you a good clue as to when you're done dividing if you do line those up. Any issues so far? First term inside, divide by first term outside, put your answer on top. Take that answer now and multiply it by everything on the outside. So what that's going to do for me, x squared times 2x there is going to give me 2x cubed. That should always be that first term because that's why we took it out to the side and divided so that it works perfectly. Then I also take that x squared times the 1. X squared times 1 gives me 1x squared. Again, we line up underneath based off of exponents. So the x cubed goes under the x cubed, the x squared goes under the x squared. Now, what operation do we do in long division now? Do you remember what you do here? Subtract. I show subtraction on every single term because a lot of times you'll forget and just combine like terms without subtracting. My 2x cubes cancel. My 11x squared minus x squared gives me what? 10x squared, and then you bring down the next term and do the whole process all over again. So starting just where we started the last one, the next row now, we take the first term inside. So first term inside, divide by first term outside. Again, I'm going to go out to the side here. 10x squared divided by 2x. This time, what's that going to give me? 5x. Where do I line that up on the top? Over the 9x right here, because they have the same exponent. And just like we did the last time, what do we do with that 5x now? Multiply by both things outside. So 5x times 2x gives me what? 10x squared. That should always be like that because that first term's always going to cancel out. 5x times 1 now will give me what? 5x. And what do I do with these two? We subtract. My 10x squareds cancel. 9x minus 5x gives me what? 4x. And then for our last step, what do? Okay, first bring down the 2 and then go after that 4x in the last step. So just like the previous 2 steps, we take the first term inside, which is that 4x, divide by the first term outside. So when I come out to the side here, take 4x divided by 2x, what is that going to give me? 2. Again, that's why we line these up, because now do we have anything else to line up on the top? We've run out of space. This tells me this is going to be my last step. So now I take that 2, I multiply it by everything outside. What's that going to give me? 4x plus 2. These will not always work out this nicely. We picked a good one to start with. When I subtract, it gives me a remainder of what? 0. So my answer to this division problem is what? What we have on the top there. X squared plus 5x plus 2. If you wanted to check your answer, you could take your answer, that x squared plus 5x plus 2, and multiply it by what you were dividing by. You should get the original first set. So you can always multiply those back together to see what your answer is. Any questions on that process? We will not do too many of these where we do long division. The reason we use long division is mainly for things like 2. You cannot use synthetic division when you have an x squared power, like you see in question 2. If you're dividing by anything with an x to the first or lower, you can always use synthetic division. So I could have done synthetic division with question 1. We just chose to do long division to show a good, easy first example. But when you get things with x squared powers, like in question 2, you must use long division. So that's the reason that we use it. So let's try this again with example 2. And then I'll give you a couple questions to practice at your tables. All right, so on 2, when we set this up, we do have to watch out for a couple things on question 2. First, when you are dividing and setting this up, remember we said if you are missing any powers on the outside or the inside, you must put in a 0 with a placeholder. What are we missing on the inside? What exponent? We're missing the x squared power. So that means when I set this up, I start by writing the first terms, but when I get to the x squared, I must put in a 0x squared before continuing on. You need that x squared so that things line up correctly. If you forget it, you're going to have a hard time subtracting. You're going to have a hard time figuring out how everything else goes. Okay? So, let's review this process. Where do I start? First term inside, divide by first term outside. So again, if you have to come out to the side here, 5x to the 4th divided by x squared is going to give me what? 5x squared. Good. Where am I going to line that up? Above the 0. That's why we have that 0 there, because we need a spot to line that up. Once I have that 5x squared out there, what do I do with it? Multiply it by all 3 terms on the outside now. So 5x squared times x squared gives me 5x to the 4th. 5x squared times negative 3x gives me negative 15x cubed. And 5x squared times 4 gives me 20x squared. Again, that's why we need that x squared term with the 0 so that we have something to subtract this from now. Now here's where I do show my subtraction for every single term, because we're going to have to be careful with that middle one, right? 5x to the 4th minus 5x to the 4th, what are we going to get from that? 0. When we subtract the next one, 2x cubed minus a negative 15x squared, minus a negative turns into a what? Positive. So that's going to give me 17x cubed. And when I subtract the third term there, I'm going to get negative 20x squared. Before dividing the next term, I have to bring down the 9x. I have 3 terms on the outside, so I need 3 terms on the inside to line those up. So then where do I go next? what do I divide? 17x cubed, first term on the inside, divide by what? The first term on the outside again. So I take my 17x cubed, I divide by x squared. What's that going to give me? 17x. Where do I line that up? Over the negative 9x. And I take my 17x and I do what with it? Distribute it to everything outside. That's going to give me 17x cubed minus 51x squared plus 68x. And what do I do with all three terms now? Subtract. So I got to be careful with my negatives again. 17x cubed minus 17x cubed cancels. Negative 20x squared minus a negative turns into a plus 51x squared. So what am I going to get there? 31x squared. And then negative 9x minus 68x gives me negative, what? 77x. Okay, two reasons I know this is my last step. I'm bringing down this last term, the 12, so I know this is going to be my last division. When I divide the first term inside, my 31x squared, divided by my first term outside here, the x squared, I get 31 there, right? That's the other reason I know this is the last step, because I'm lining it up over the constant term right here, which means I've run out of room. I take that 31 and I do what with it? Distribute it to the outside. That gives me 31x squared minus 93x plus 124. When I subtract, again being careful of my negatives, my x squared terms cancel. How many x's am I going to have? Negative 77 plus 93 gives me what? 16x. And 12 minus 124 gives me negative 112. Can I divide that anymore? Negative 77 plus 93?
Would you not do minus 93?
No, it's minus a negative. It turned into a plus. You could factor that out, but I don't have to, because this exponent is an exponent of 1. Outside, what's the highest exponent? X squared, which means I'm not going to be able to divide anymore. So I leave that alone now. Okay? So how we write our answer? Our answer is what part? What's on top there? 5x squared plus 17x plus 31. How we write remainders, which is what we have down here. This whole thing is our remainder. We write plus our remainder of 16x minus 112 over what we were dividing by to begin with, which was what? X squared minus 3x plus 4. Okay? So that is how we write remainders. You write what you got as your remainder over what you were dividing by to begin with, because basically you're saying this didn't divide by this, so that's kind of what's left over. Any questions on that? The key for synthetic division here is that you must be dividing by a linear factor, x minus k. It doesn't mean that you cannot have a number in front of the x. It just means that whatever you're dividing by, it must only have an exponent of 1. So the x must only have an exponent of 1. You cannot use synthetic division when you are doing something with an x squared. So for something like what we see for 3, it's basically the setup. You set your factor equal to 0, either mentally or actually do that to solve it. Whatever number you get from that goes on the outside. So in this case, what number would go on the outside? -2. That goes on the outside. you draw a box for this that looks something like this. You're only going to use the coefficients of the numbers on the inside. Remembering that if you have any missing terms, again, you must use zeros. So for 3, I start with a 5. I'm missing an x squared, so I must put in 0, then 6, then 8. So there's our setup. Set your factor equal to 0, that number that goes outside, and then put all of your coefficients on the inside. Always bring down your first coefficient directly, put it outside, and then multiply the numbers on the outside. So negative 2 times 5 gives me what? Negative 10. That goes directly up here under the 0. The only difference between synthetic and long division is here we do not subtract, we add. 0 plus negative 10 gives me negative 10. That goes outside again. Now multiply the factor outside on the left by this number. Negative 2 times negative 10 gives me what? Positive 20. That goes up under the next one. And you add again. What do I get here? 26. Okay. Negative 2 times negative 26 gives me what? Negative 52. When I add down my last column, that's going to give me what number? Negative 44. Now, how you write your answer out, you start labeling from the last number that you got. The last number I get is my remainder. Before the remainder goes the constant, then the x, then the x squared, and you just keep labeling out forward, going higher in exponents as you need to. So my final answer for this, if I wrote it out, is 5x squared minus 10x plus 26. And then let's review, how do we write remainders? Over what you were dividing by to begin with. You can put plus with a negative in front of the 44, or you can put a minus. It doesn't really matter to me, honestly. So the only thing that's going to get a little bit confusing with synthetic division is the fact that we can do 4 different things with it. About 4 different things. Okay, this first set, 3 and 4 here, it's just asking us to divide. Okay, so make yourself a little mental note or a little actual note. When it's asking me to divide, my answer is a polynomial. It could be a polynomial with a remainder. It could be a polynomial without a remainder. Either way, it's a polynomial with x's and all of that in it. Okay? Let's practice that one more time before we do other types. But the good news is that synthetic division, once you learn the process is the same the whole way through.
So if that 8 had been a positive 52, would there be no remainder?
There would be no remainder on that, yep. All right, so let's set up 4. What number is going to go outside? 1. Inside, when I set up my coefficients, I need to remember if I am missing any terms, they've got to go in as zeros. So I do a 4 followed by what? 0. A negative 2, 1, and 1. First step is to do what? Bring down the 4, bring it outside your box. So that 4 comes directly down. What do I do with it? Multiply by the 1 outside. So 4 by 1 just gives me 4. Add down your columns. That gives me 4 again. Okay? Finish this one out and write your answer out in polynomial form for me. Any issues with this basic form of synthetic division? Typically, your answer should have one lower exponent to start with. So notice I started with a 4x to the 4th. My answer has an x to the 3rd to start with. So you're dividing out one x, which means everything should go one lower. That's typically how that works. All right, on the back real quick. Next thing we can do is synthetic division. You can do something called a a synthetic evaluation. It sounds difficult. It's not. It's the same setup. Okay? So when it says to evaluate, okay, this is the second thing we can do with this. Your answer is a number. Okay, so synthetic evaluation works the exact same way, only it's solved for x already. So when they give me an x value, that means that is the number that goes outside. If they give me a factor where it says x plus something, x minus something, then I have to solve it. But if it's already solved for x, that goes directly outside. So on this first one here for 5, we put -2 directly outside and start with our coefficients inside. So in this one, I do 3, 8, 5, -7. We follow the same exact synthetic process. So take a minute, do that on your paper. Okay, so hopefully this process is getting pretty quick for you. The answer is a number for this. So we're not going to write out the entire polynomial. We don't care about that. The answer for this one is the remainder. So what we've actually done here, evaluation, typically that means take out your x, plug in that number. So that's like if I asked you to do f of -2, because -2 was the number we plugged in. In the past, what have we done for f of -2? We've gone in here and we've replaced all of the x's with -2 and we've multiplied that out, right? You can still do that. That's a way to do it still. It's not wrong. But let's just say this is on a non-calculator section. If I gave you that polynomial and asked you to do f of -2, you'd have to take -2 cubed, multiply it by 3, -2 squared, multiply it by 8, -2 times 5, and add up all your terms together. Is this math a little bit easier to do? Yeah, to me it is too. You would get the same answer either way. If you plugged in -2, you'd get out -9. If you do synthetic evaluation, your remainder is the answer that you would get. So it's not any different. It's just a quicker way to do it. Okay? On 6, what number are they asking us to plug in? -1. So take a minute on your paper, work that one out. Check your answer against mine. We should have gotten an answer of 1 back out from the remainder. So your answer is actually that 1 right there. Any problems with that? All right, real quick, we're going to pause. And the last thing with synthetic division is called the factor theorem. So this is the main reason we use synthetic division. We use it to factor when we don't know how to solve otherwise. So for something like 7 that has 5 terms, we have no way of factoring that. None. So if you had to graph it or you had to do some other step with it, you wouldn't be able to solve this without using synthetic division. So in 7, when they tell me that something is a factor, remember when they give me factors, before we divide by those, what do we have to do with them? Set them equal to 0. The difference between 7 and 8, 7 gives me factors. So that's where I have to set them equal to 0. 8 gives me what? A 0, which means that's already solved for. So that means that's the number that would go outside, whereas on 7, we have to solve those, okay? So we're going to start. It doesn't matter whether you start with 2 or you start with -3. It's your choice. The main thing not to screw up on these is that when they give you 2 different factors like they do here, you start with the first one, but when you do the second one, we're going to build off of what we've already done. You're not going to go back to the beginning. So you're going to see that in just a second. So when I set this one up, I don't have anything to skip here with my zeros. So I'm going to go ahead and put in my 2, 7, -4, -27, and -18. This is a lovely long one to divide here. And we'll do our synthetic division real quick. Now notice what happens when they tell me something is a factor or it is a 0. What do we get for a remainder? 0. That will always happen for those. Okay, we're trying to factor this out. That means you can't have a remainder, right? So if they tell me something is a factor or it is a 0, that gives you a little bit of a hint. If you work that out and you don't get 0 as your remainder, that means you've done something wrong. Go back and check it. So if it's a factor of 0, you must get a remainder of 0. Now here's what I mean by continuing off of what we've done. They've also told me that x plus 3 is a factor, so I can divide in -3. You do not go back to the beginning. We're trying to break this down. If we can't break this down, that means we don't have any other methods to use for this. So I'm going to build my next synthetic division off of where I just finished. Notice I'm not including that 0. Why not? It's a remainder of 0. It's not actually there. It's not part of my problem. So when I divide in -3, I'm going to use what I just got to keep going from there. So now I bring down my 2 and I complete my synthetic division using this. I also expect this one to give me a remainder of 0 because it told me this was a factor. All right. So now that we have this, let's read what the question actually wants us to do. Find the remaining factors, list all of the zeros. That means I have to completely factor this out. So let's look at what we have here. This is a remainder of 0. Remember, this is our constant term, our x, and our x squared. So if I wanted to write this in factored form, so far what have we factored out? The first division, we factored out an x minus 2, right? The second division, we factored out what? X plus 3. That was the second factor they gave us. What did we have left then when we divided both of those out? 2x squared plus 5x plus 3. So far, that is my factored form. If that's as far as I can go, great. If it's not, I need to continue factoring. Okay, we've broken this down to the point that all we have left is an x squared. We should know how to factor something like that, right? So if I continue factoring this, I have x minus 2, x plus 3. Now, let's review our factoring for that. 2x squared is what times what? 2x and x. Factors of 3, we know they both have to be positive according to our signs. The only options we have for 3 are what? 1 and 3. Where does the 3 have to go? On the 3, for this to multiply out, we want it to be a 3 there and a 1 here. We check this by saying that gives me 2x, this gives me 3x. Does that add up to 5x in the middle? Yes. So that is how we use this to factor. Any issues with where we got all of these factors? The x minus 2 was the one we divided first. The x plus 3 is one we divided second, and then we got the other 2 out of our answer. If they ask me to find factors, that's where I stop, right? Because it's the parentheses. If they ask me to find zeros, what do I do with each of those? We set them all equal to 0. So in this case, I have 4 answers. What are they? 2, -3, -3, -1, and -3/2 or 1.5, either way. Could we then graph this based off of what we've done in the past? These are all single roots, multiplicity 1. It's a 4th degree with a positive leading coefficient. Both ends would go up. We could graph the entire thing. Okay? All right. Let's try that one more time with 8. We'll practice for a minute and be done. In 8, they've only given me 1 0, and that 1 0 is 7/2. Remember, if they give me a 0, that is the number that goes outside. I do not have to set it equal to 0. Do I have anything to put in a placeholder for on this one? No, so I can go straight down the line. You just have to be careful when you're doing 7/2. The nice thing is when I do 7/2 times 2, what happens? It just becomes 7. Notice that this one's not too bad because when you add down each of these, they become even numbers, which makes them a little bit easier to multiply. So if you can't do these, remember you can do 7/2 times -8/1. That gives me -56. Divided by 2 gives me what? -28, I believe. When I add down my columns, that gives me 6. 7 times 6 is 42, divided by 2 gives me 21. Again, you should know that that's going to work out to 0. Why? Because it's a 0. That means it has to have a remainder of 0. All right, so now here's the weird thing with factoring on this one. They gave me a 0, 7 over 2. How is that? How could I write that as a factor? I could write it as x minus 7 over 2. Any other way we can think of writing that if we don't like fractions? I could write it as 2x minus 7, because if I set that equal to 0, you'd add the 7 and then divide by 2. Either way would work for me. What do we have after that as our answer that we factored out here? 2x squared minus 8x plus 6, which we would then try to factor. If I was factoring that, what would I get? Or what would I do first? Take out a common factor of 2. All right. Once I take out my common factor of 2, what does that factor into? What factors of 3 add up to negative 4? Negative 3, negative 1. And what would be my zeros then? 3, 1, and 7 over 2. Remember, the highest exponent tells you the number of zeros that you should have. So notice on this one, my highest exponent originally, 2x to the third. How many zeros do I have? 3. On the last one, it was 2x to the fourth. How many zeros did I have? 4. Okay? So you just need to be able to read directions on these. Make sure that you list either the factors or the zeros. All right.